Okay, so it looks like it's recording. So this is 7.4. It's integration of rational functions by partial fractions. There are techniques here that are going to be important for you to understand. So hopefully we don't have any recording issues because you're probably going to watch this recording like 3 or 4 times. And that's just the truth of the lift that we're doing today. The last 2 days or the last 2 sections that we did were not bad compared to what we're about to do today. All right, so let me get into it. Try and stay as focused as you can. And here we go. So this first integration problem that we have here, we can see that we have an improper rational function, correct? You guys remember that from your Algebra 2 class? And so, in order to be able to attack this problem, what we need to do is we need to be able to do long division to this problem. And so to do the long division, I'm going to go x cubed plus 0x squared plus x, and then I'm going to divide by x minus 1. And so I need x squared, so I'm going to get x squared x cubed minus x squared, and then I'm subtract, and so I'm going to end up with x squared plus x, and now to get that to match, I need to multiply by x, and that's going to give me x squared minus x, and then when I subtract, I should end up with 2x, correct? And then what I need there is I need a 2. So I'm going to get 2x minus 2, subtract it, and I'm going to end up with 2. Does everyone agree with this process so far? Right? It's just long division. We should be all right. So now what I'm going to do is I'm going to rewrite this in a way that I'm going to rewrite the integral so it's equivalent to this breakdown that I've done. So I'm going to rewrite it as x squared plus x plus 2 plus that remainder of 2 over what I divided by, which was x minus 1. This is the equivalent integral, right? We can do the first 3 very, very easily, correct? The first 3 are very easy to do, and we can see that there I'm going to get x cubed over 3 plus x squared over 2 plus 2x. And then this last one is actually fairly simple too. It's 2 ln of x minus 1 plus some constant c. Any questions? I did that quick.
Inside the division sign, is that a 0x squared or?
Correct. Right here, this is a 0x squared, and the reason you need the 0x squared is because you need your placeholders for the descending polynomial.
Oh yeah, okay.
Yeah, if you don't put that 0 there, then you're going to make some mistakes.
For sure. Thank you.
Mm-hmm. Anything else? No, we're okay? All right. Well, then let's continue with the next problem. Now, with this problem here, again, we have an improper, so again, we have to do our long division, or never mind. It's not improper, silly. And since it's not improper, we need to find a new technique to attack this problem here. And so what we need to do is we need to see, looking at the denominator, can we factor it somehow? And so we're going to try to do that. So I'm going to take an x out of the denominator, So I'm going to get x, I'm going to get 2x squared plus 3x minus 2. And then I see that that is factorable, so I'm going to get x is equal to 2x times x, and this is a 2, that should be a plus, that should be a minus 1. That is the equivalent product of the denominator that we had. Do you guys agree with it? Okay, here comes the lift. Now we're going to do the partial fraction decomposition of this problem. Because the denominator is a product of things, I'm going to rewrite this quotient as this. There's three products, right? There's the x, the 2x minus 1, and the x plus 2. And so the way I'm going to write that is I'm going to go ax, a over x, plus b over 2x minus 1, plus c over x plus 2. Now the goal is to do cross products and get the common denominator, and then write things in terms of a, b, and c. So when I do this cross product, or this multiplying that I'm going to do, I'm going to get a, to get common denominator, I need to multiply by 2x minus 1 and x plus 2, plus then b is going to need x and x plus 2, and then c is going to need x and 2x minus 1. Are we in agreement? Okay. Very cool. So then from here, what I need to do is I need to do an expansion of this thing. And really what's going on here is now we know the denominator is going to be the same. This is equal to the numerator. Okay? Just trying to remember your partial fraction decomposition. And so when we expand this, I'm going to get 2ax squared minus 3ax minus 2a plus bx squared plus 2bx plus 2cx squared minus cx. Is everyone okay with that?
Yes.
Okay. Now from here, the way that I typically solve these is I turn them into matrices. If you're not comfortable with matrices, you can solve them by systems, but matrices to me are so much quicker. But whatever. So I'm going to look at the x squared terms, and I'll just highlight them. So this is an x squared term, this is an x squared term, and this is an x squared term. So 2a plus b plus 2c should equal my x squared term on the numerator side of the original problem. So that should equal the coefficient. What's the coefficient of the numerator for x squared?
1.
It's 1. Now, I'll use a different color. I'm going to look at the x's. So I have a negative 3x, 2bx, and a negative cx. So what I'm going to get there is a negative 3a plus 2b minus c should equal a positive 2, correct? We're okay? And then the non-highlighted piece, it's that minus 2a should equal a negative 1. Right? So then from here, a is easy to find. We can see that a is equal to a 1/2. From there, we can find b by using elimination. I'm not going to show that. That's something you guys should have learned in Algebra 2. That's going to give me 1/5. And then c will give me a negative 1/10. Is there any questions on how we get a, b, and c?
Yes, how'd you get the negative 1 for the third row again?
This negative 1?
Yeah.
Okay, so it comes from here. That's the numerator piece, right? The x squared term had a coefficient of 1. That gave me this one. The x had a coefficient of 2. That's this 2. And then the constant term had a negative 1. So that's equal to negative 1.
Okay, thank you.
Okay, so then there's a, b, and c. And now we need to use those to be able to do this decomposition. So now the integral that we're going to result with is going to use this piece here because that's equivalent to this with the a, b, and c that we found. So I'm going to get 1/2 times 1 over x plus, it was 1/5, 1/5 times 1 over 2x minus 1 plus, it becomes a minus 1/10 times 1 over x plus 2, and this is all dx. Are we okay with this? This integral that I just created is equivalent to this one. We okay? Okay. You're not speaking. Kind of causes a little bit of concern. But okay, I'm going to break it up into 3 integrals. So I'm going to get the integral 1/2 of 1 over x dx plus 1/5 integral of 2x minus 1 dx minus 1/10 the integral of 1 over x plus 2 dx. Okay, and so that's going to give me 1/2 ln of absolute value of x plus this will be 1/10 this should be over 1, so over 1 ln of absolute value of 2x minus 1 minus 1/10 ln of x plus 2, and then plus some constant c. And let me do this. This is our solution to this problem. Okay? Any questions on the breakdown of this problem? Anything at all?
Professor, how did you get the 1/10 on for the final answer? 1/10 natural log of absolute value of 2x.
Right here?
Yeah, did you multiply the denominator?
No. So I've already taken into account that you know some things from the previous sections. So this one here, in order to be able to do it, this integral I did a use of.
Okay.
So I'll show it just so you can see it. But yeah, this is where now we're doing some lifts that you guys should know. But it's okay. Better you ask, because I bet you there's a few people in here that are like, what the hell just happened? And they didn't want to ask. So I'm going to say u is equal to 2x. Ooh, that's a minus 1. So then du is going to be equal to 2 dx. So 1/2 du is dx. You see it? So
Yeah.
now I have 1/5 times 1/2
1/2.
integral of 1 over u du. And that's where I got the 1/10.
Natural log. Okay. Thank you.
Got it? Okay.
Yeah.
Cool. Can I erase it?
Yeah.
All right. Any other questions on this? We're okay? All right, moving on. All right. So in this problem here, do you notice that we have an improper again? Now it's x to the third and x to the fourth. So again, because we have this improper, we want to do our long division. And so now, bear with me, I gotta write this thing out. I'm gonna get x to the fourth minus 2, oops, I almost messed up, minus 0x to the third minus 2x squared plus 4x plus 1, and then that's going to be divided by x to the third minus x squared minus x plus 1. And the process here, I'm going to get multiplied by x, so I'm going to get x to the fourth minus x to the third minus x squared plus x. That's going to give me x to the third minus x squared plus 3x, and then I'm going to bring down the 1. And then I'm going to go plus 1, which will give me x to the third minus x squared minus x plus 1. Subtracting that, I'm going to be left with 4x. Right? So then my breakdown of this is going to be an integral that's going to be x plus 1 plus 4x over this denominator that we have. Are we okay?
Yep.
Okay. Now, this problem here becomes convoluted because we can do the integration to the first two parts no problem. Like, those are easy. But here, we run into one heck of a problem. So there's something that has to be able to be done with that denominator. And it turns out there is. We can factor it. And x cubed minus x squared minus x plus 1 is equal to x minus 1 times x squared minus 1, which will equal x squared minus 1 times x minus 1 times x plus 1. You're going to ask me, how did I know that? Right? I use synthetic division to do it. So my P and Q here to find rational factors were plus or minus 1, right? And so by doing that, I was able to find the factor. Does everyone know what I'm talking about synthetic here? Does anyone need me to show it?
Yeah, can you show it, please?
Sure. So if I do synthetic to this just to find the factors, right, with our P and Qs, I'm going to have 1, negative 1, negative 1, 1. And which one do you want me to use? Positive or negative 1? I don't care.
Positive.
You said negative? Okay. So we always use the opposite sign. So if I'm going to use x minus 1, it's going to be 1. If I'm going to use the positive root, I'm going to use the x plus 1. Okay? So then from here, this one comes down. And then what's negative 1 times 1?
Negative 1.
That's right. And then that goes up here. So negative 1 plus a negative 1 gives me a negative 2, right? But negative 1 times negative 2 is 2. And that gives me a positive 1. And then what's negative 1 times 1? Isn't that a negative 1? So that gives me a remainder of 0. That tells me that it's a factor. Okay? So then from here, I'm going to get x plus 1 times this thing that's left. Right? Because this was x cubed, x squared, x, and constant. It reduces a power when you write that bottom row, correct? And then this factors to become x plus 1 times x minus 1 times x minus 1, which gives me x plus 1 times x minus 1 squared, which is what I want. Is that coming back to some of you? Okay, so then from here, I'm just going to deal with the, for that last piece. I'm only going to deal with this part of the integral for now. And then when I go to complete the integral, I'll write everything down. So 4x over x cubed minus x squared minus x plus 1 is equivalent to a times x, we'll just do it this way. Actually, let me do the repeating first. Plus b over x minus 1 repeated, because now it's a square, right? Plus c, which will be the x plus 1. That is the breakdown of this repeater. And the reason that it's called a repeater is because we have a base raised to an exponent. Does that make sense? You're going to be remembering a lot of partial fraction decomposition here. Okay, so then when I go to expand this, I'm going to get a times x minus 1 times x plus 1. And the reason that it's multiplied by x minus 1, because this has x minus 1 squared. So this one would need an x minus 1 and an x plus 1 from this factor, correct? My b is only going to need x plus 1 because it's got the x minus 1 factor already. And then c is going to need x minus 1, that term squared. Now they all have a common denominator of x cubed minus x squared minus x plus 1. Make sense? This top portion is the numerator should equal 4x. Now from here, expanding, I'm going to get ax squared minus a plus bx plus b plus cx squared minus 2cx minus c. Agreed? So my squared terms are going to be a and c, so a plus c, and that should equal what? What's the x squared term here?
It's supposed to be negative 1?
Negative 1. No, right here. What is that piece right there? What's the x squared term?
0?
0, exactly. So that should equal 0. Does that make sense to you guys? Is there an x squared term here with the 4x?
No.
No.
I see.
So then x squared has to be multiplied by 0. And that's why I get 0. Now, when I deal with the x's are going to be b and a negative 2c, right? So b and a minus 2c. And what is that supposed to equal? That's supposed to be the x term.
4.
It's supposed to equal 4. And then we have a constant. We have two constants, right? We have, we have three constants. We have a minus a plus b minus c should equal the constant. And what's the constant?
0.
0. Does that make sense? So this would be a matrix. So if you want to solve it in matrix form, you guys could. It would be 1, 0, 1, 0, 0, 1, minus 2, 4, negative 1, let me make sure you get that to be a 0, 1, negative 1, 0. And if you know how to use your TI, you can put
Can you scroll down a bit?
Scroll down or back up?
No, down. You can't see.
Oh.
Yeah.
Okay, sorry. I can't see what you guys can see. So here, what you could do is if you have a TI 84, you could go to reduced row echelon form, and that will spit out the answer. For those of you who used your TI, that's how you find it. It'll spit it out, and it will give you this. It'll spit out this. 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, negative 1. So this represents A, this represents B, this represents C. So A is equal to 1, B is equal to 2, C is equal to negative 1. You guys with me? But if you don't want to do it that way, you can do a system of equations with that matrix, or with the 3 variables, 3 unknown equations.
So you input that, and then it's gonna give you this after.
Yeah. So you put this in your calculator,
Go
to reduced row echelon form, and it'll spit this out.
Okay.
Yeah. When I teach Math 70, I show my students how to use their calculator to do that, so they can verify their work. Okay, so let's continue. So now I have to take the integral of this thing, right? But now I know what A, B, and C are. So let me go all the way back up. Dang, that's a long way. I'm going to get the integral of, now let's not forget the beginning piece, right? X plus 1 plus, now we can do the A, B, and C piece, which is going to be 1 over x minus 1 plus 2 over x minus 1 squared minus 1 over x plus 1. This whole thing is a dx. Does everyone remember where we had the x and the plus 1? It was from right here, from the long division piece, right? This breakdown right here of these three come from this being broken down.
Can you say that again?
Yeah, so see how when we did the long division, we got these two pieces, right?
Yeah.
That is this piece. When we broke down this to decomposition, that gave us these three.
Okay, thank you.
Right? Because the decomposition of that is right here. Right?
Yeah.
And then we found A was 1, B was 2, and C was a negative 1. So there's A, B, and C. We okay? And now it's the easy part, the integration, right? The integration is nothing. So what is the integral of x?
X squared over 2.
It's x squared over 2 plus x. This next one, we have it down now, is ln of x minus 1 plus this one is just going to be 2 times x minus 1. Oops, my bad. 2 over x minus 1. And then this last one's going to be ln of x plus 1. And then let's not forget our constant c. Okay? But I can clean this up, and I probably should clean it up. I probably could have cleaned up the one before that. I can go x squared minus 2 plus x plus 2 over x minus 1 plus ln of x minus 1 over x plus 1 plus some constant c. I use the log rules here. That's ln of x minus 1, and that's a minus ln of x minus 1. So remember, in logs, that minus means division. So I got ln of the x minus 1 divided by the x plus 1. And so this is my solution.
This really is like everything put together.
Oh, look, this is every math class that you've taken put together.
Literally, you have to take everything into consideration.
Everything.
Wow.
So it's a big lift, because this is going to show how much of your math you truly remember. I mean, system of equations, partial fraction decomposition, making sure that you know your integrals and derivatives well, it all comes to play here. And then 7.5, the next section that we'll do, which we're not covering today, we're only doing 7.4, is all of them mixed up. So it's different integrals, and you need to know by looking at the problem how to attack it. So this is going to take some time to truly understand. And hopefully my recording doesn't mess up today, because this is something you'll probably want to watch more than once. Okay, any questions on this breakdown for this problem at all? Or are you just trying to, like, breathe?
So both the answers would work, though, right? You would accept both the answers?
Oh, yeah. So if you wouldn't have put them together, this would have been okay. Now, I don't know if WebAssign will be picky with that. They might not be. I wouldn't be on an exam.
Okay.
Okay. Can I go to the next problem then? Okay. One thing that I did want to stress too is right here, right, when I got this factoring piece, this here is a composition, it's a repeater, right, for the denominator, because x minus 1 comes into play twice. So we need to go from lowest power to highest power. So if this would have been cubed, I would have had to go on x minus 1 squared, and then x minus 1 cubed, right? Depending on how many powers there are. But the base of it is what dictates if this is just a, or if it becomes like a bx plus c. I'm going to demonstrate that in this next problem so you guys can see the partial fraction decomposition piece. But it's important that you guys remember that, okay? All right, do the next one. Okay, so in this one, again, this is the proper rational expression. And so we are not going to do long division here. So we need to look at the denominator and see if we can factor the denominator, right? So when we go to factor the denominator, the easiest thing that we can do right off the bat is factor out an x. So we're going to get x squared plus 4. And that's as much as we can decompose this thing. Right? Are we in agreement?
Yes.
Yes.
Is anyone there? I feel like I'm singing Pink Floyd's song. Is there anybody out there? You guys are really quiet today. I get it. Okay, so then from the breakdown of this, I'm going to go 2x squared minus x plus 4 over x cubed plus 4x. In fact, let me write it as it's decomposed. X times x squared plus 4. And what's going to happen here is with the x, I can break that down to be a over x, correct? The product of the denominator. And then plus the other denominator that I have is x squared plus 4. Well, since this is x squared, now the numerator has to become a line. It can't just be a point. It's a line. And so that's going to become bx plus c. Do you guys recall that from doing your decompositions?
No.
Okay, so here's the trick. If the power of this is, if this is linear, we're going to go to a point. If it's quadratic, we got to go to a line. If it's cubic, we'd go to a quadratic.
Okay.
So we're always going to end up one power below in the numerator. Okay? Okay, now from here then, I'm going to try and rationalize this thing, or not rationalize it. I'm going to try to see if I can break it down to find my numerator values. So it's going to be, it's going to be a times x squared plus 4 plus bx plus c times x. And that should equal 2x squared minus x plus 4. Is everyone okay with how I did that?
Yeah.
Yep.
Okay. So then I'm going to expand. So I'm going to get ax squared plus 4a plus bx squared plus cx. And then I can see I have my x squared terms are going to be a plus c, and that should equal what? What do you guys think?
2.
It should be 2. Is there anyone that doesn't understand why it's 2? You all get it? Okay. All right, then. What's that?
Can you please explain what it's 2?
Yeah. So looking at this here, I see I have ax squared and I have bx squared. Right? Ooh. I even wrote that wrong. That should be a b. So, so I have ax squared and bx squared. Those are supposed to add up to be the x squared term of the numerator's polynomial. So the numerator's polynomial has 2x squared. So ax squared plus bx squared should equal 2x squared. So a plus b should equal 2. Got it? Now, to look at the x terms, there's only one x term that we see on here. So that's c. C should be equal to what?
Negative 1.
It should be negative 1. And then our constant that we have is 4a. And 4a equals?
1.
What's the constant of the polynomial of the numerator?
What's
Is it
4?
four?
It should
You have
be.
to divide it though. That's how I got 1.
Oh no,
Okay,
you
bye.
went and solved for A. We're not doing that yet.
Oh, okay.
All we're trying to do is break down so that we have our matrices, right? So easily here we can see the answers to this. We don't need a bunch of fancy stuff. We know that A is going to be equal to 1, B is going to be equal to a negative 2, and C is equal to a negative 1. Correct? Oh wait, I'm sorry. B is 1. Right. Does everyone see that? I didn't need to use a matrix or anything because 2 of these were very easily solved. Now, this part's important. Do you guys understand how I got A, B, and C? Is there anyone that is unclear on that? I know it's an Algebra 2 topic, but you'd be surprised how many people don't know this.
Yeah, I don't understand how you got the A, B, and C.
Okay, cool. No problem. So looking at this here, from this one right here, 4A is equal to 4. If I solve that, I'm going to divide both sides by 4, so A is going to equal what?
1.
1. What's my C equal to?
Negative 1.
Okay, and we said A was 1, so 1 plus B is equal to 2, so what does that tell me B has to be?
1. 1 plus 1 equals 2. Just like
And that's how I get them. Does that make sense?
Yeah.
Okay, that's how we do these. If you're going to do them by a system of equation, but again, if you want to meet with me during my office hour, I can definitely walk you through how to use your calculator to input them into your calculator into a matrix and then solve them. Okay? I don't want you to get eaten up in my class because you can't solve a matrix. Linear algebra will do that for you, and then when you get to your master's in mathematics and start finding about eigenvalues, then they can really give you headaches. But for this class, matrices are something that I don't want to have eat you up. So just ask me and I can show you how to do that. Now, from here, we're going to go back to this right here. This is the equivalent integral, right? Okay? So I'm going to rewrite it with the numbers that I have. So I'm going to say the integral of 1 over x plus x minus 1 over x squared minus 4 is my new integral. Do you guys agree?
Yeah.
Okay. So then from here, there are some tricks that I'm going to show you. The first one's very, very easy, right? 1 over x dx. This one here, I see that if I were to break it up to go x over x squared minus 4 dx, I could do a u substitution to it, right? So I'm going to break that up to make my life easier. And then I'm going to use this last one here. Now, the first one, that's easy, right? ln of x. This second one was a u, getting rid of the ln on top, and so I'm going to get 1/2 ln of x squared minus 4. It's an integral that we've done before. If you need me to show it, I can show it. I don't mind.
Professor, wasn't it x squared plus 4?
Was it? Oh, it's plus 4. Plus 4. Cool, thank you. Plus 4, thank you. Yeah. Okay. Now, this one here, there's a rule that we're going to use, and this is something that you should know. The integral of d of x over x squared plus some ax is going to be equal to 1 over a tangent inverse of x over a plus some constant c. That's a rule that you should know. It would just save you time, and it's because we could have broken it down and used trig substitution with this, but it would have gotten kind of crazy and ugly. So instead of attacking it that way, let's look at it this way, okay? So then from here, this piece is going to become 1 over, my a now is what?
2.
2, good. Tangent inverse of x over 2 plus some constant c. And that is the answer. See that bugs me. Any questions on this one? Any questions on how I got this? You guys have seen it enough now that you get it? What did I do there? Doesn't this become the u? Right?
Yeah.
Are there any questions on it, or you feel okay?
Divided the 2, right? And then that's how you got the 1/2.
So here, let me just show it.
Like a U sub?
Yeah, so I did a u sub. So that integral there, just so you guys can see, I said u is x squared plus 4. You know, after you spend enough time doing these things, you just kind of see it. But I've been doing this for 20-some years, so I will take it for granted sometimes, and so I don't want to do that to you guys. That's why I kind of push and prod to see if you actually get it. So 1/2 ln of, it's going to be u in the denominator now with du on top. So what does that give me? 1/2 ln absolute value of u plus some constant c, but we know that u is x squared plus 4 plus some c, and that's how I got that middle term. Okay? But the highlighted piece is the answer to this whole problem. You start to see, you do enough of these problems and you're just being reinforced the same integral again and again and again. How many times are you guys seeing now ln, and it's getting to the point where it's just so natural, just be like, oh, ln, right? So after you do this homework, you'll go back to your Calc 1 friends and be like, oh, hell yeah, that stuff's easy, dude, I got you, right? Like, oh, what derivative, dude, I got you, I could do that too. So, yeah, what Calc 2 builds on Calc 1, right? So, and it gets ugly, and the amount of work that's demonstrated in these problems can be daunting. So you can see how there is easily mistakes made, right? A sign here, not distributing a number there. You got to be very, very meticulous about what you're doing as you're doing it. Okay, so let's do the next problem. So now in this problem, we end up seeing that they're to the same power, right? And if they're the same power, the trick here is, again, I'm going to use long division, okay, to try and simplify my integral. And so I'm going to go, all right, 4x squared minus 4x, oops, I don't want to waste space. 4x squared minus 3x plus 2, and then I'm going to get 4x squared minus 4x plus 3 I'm going to use for long division. So what do I want to multiply? What do I want to put up to multiply with the denominator? Isn't that 1? Right?
Yeah.
So I end up with 4x squared minus 4x plus 3. And then I'm subtract, and I see that's going to go away. I'm going to end up with a positive 1x minus 1. Correct? So now the new integral that I end up having looks like this. It's equivalent to the one that we had. It's going to be 1 plus x minus 1 over 4x squared minus 4x plus 3. Right? But again, in this problem, we run into an issue with that second term, right? The x minus 1 over the 4x squared minus 4x plus 3. Problematic. So that means we have to do something to the denominator in order to be able to manipulate this problem. So I'm going to break it up just so you guys can see it and see if I can do something to this denominator to help me clean this up. Well, I know it's not factorable, right? And I can check that by checking the discriminant if I wanted. If it isn't equal to 0, then I know it's not factorable. So I know it's not factorable. So what I'm going to do to this problem is I'm going to manipulate it like no get out. Okay? So I'm going to take 4x squared minus 4x plus 3, and I'm going to divide everything by 4. So I'm going to get x squared minus x plus 3 over 4. And then I'm going to complete the square on this piece, and to complete the square I have to add 1/4. But if I add 1/4, that means I have to subtract 1/4, correct? So that's going to give me x minus 1/2 squared plus 1/2. And I could have done it without without having to do the multiplication and division, but I'm weird, I like to. And so now I'm going to multiply inside, and I'm going to get 2x minus 1, quantity squared, and multiplied by 2, right? And if that's squared, it comes out as a 4, right? A 1/4 plus 1/2. And then I don't want a fraction there, so I'm going to multiply by 4, and I'm going to get 2x minus 1, that quantity squared, plus 2. Another way you could have done it, and it would have been ugly but cool, you could have done this way. And then completed the square and gone from there to do it. And that would have ended up with the same thing. Okay. So now I can rewrite this integral to be integral of dx plus x minus 1 over 2x minus 1 plus 2. That's not neat. Sorry. Integral of x minus 1 over 2x minus 1, that quantity squared, plus 2 dx. We all right? So now this doesn't really seem helpful to me, but it will be, because now I can do a u substitution. It's the techniques that we've learned. And so I'm going to make my u here 2x minus 1, because it makes my life look so much easier, right? So much cleaner. So from here, I'm going to get du is equal to 2dx, or 1/2 du is equal to dx, right? But here's what happens. I'm going to have my integral of the dx plus, I'm going to have the bottom piece, no problem. That's the bottom. I'm going to have the 1/2, that's no big deal. I have my du, but I have x minus 1 still. So what do I need to do? I need to come here and solve for x. Okay? So in order to be able to get rid of the x that I have left, I'm going to go u plus 1 is equal to 2x. So then u plus 1 over 2 is equal to x. We okay? So, in fact, I'm going to clean this up because I think it's better. I'm going to make this a 1/4 and then get my u plus 1. And the reason it's a 1/4 is because, let me make this smaller so it can be more precise. Cool. Here I could have written this instead of over 2, I could have written it this way. And maybe that makes it easier for you to see. The 1/2 from here with the 1/2 from here yields that 1/4. Right? And so now we have some trickery, right? We have the integral of a dx, which, all right, that's cool. But over here, I'm going to break it up. I'm going to break it up to be u over u squared plus 2 du plus 1/4 integral of 1 over u squared plus 2 du. We have some integrals in x and we have some integrals in du. Well, we can't live in the land of u's. We're going to have to integrate them and then substitute them back in, right?
Professor, I have a question.
Yes.
So if you substituted u plus 1 for x, what happens to the minus 1 that was originally there? Wouldn't those cancel out and just be u?
Hold on. So let me see if I can demonstrate that for you. Let me see. So you're talking about from here to here, correct?
Yeah.
Okay. So here's the way you want to look at it. So so if my x is 1/2 of u plus 1, how do I get the plus 1? That's true. So let me see. Going on autopilot on this stuff. So let me show that work. It does look like it's just, let me see. I'm just going to do it. So then I'm going to go 1/2 u plus 1/2 minus 1 should give me 1/2 u minus 1/2. Oh, so this should be a minus sign. That should be a minus. Thanks for pointing that out. Do you see it?
Yeah, I see it now.
Yeah. So that should be a minus. Okay. Thank you. So then from here, I'm going to get x plus, this is going to be 1/4. I'm going to do a u substitution to this. So it's going to become 1/2 ln of u squared plus 2, right? And then this here is, again, a rule that we already used, but I want to bring it back so you guys know it. Dx over x squared plus a squared, remember, was 1 over a tangent inverse of x over 2 plus some constant c. So using that, I'm going to get 1/4. My a is radical 2, right? Tangent inverse of, we're going to get u over radical 2 plus some constant c, but we can't leave it like this. We need to substitute in what u is, correct? And so when we substitute in, I'm going to get x minus 1/8 ln of 2x minus 1 squared plus 2 minus 1 over 4 radical 2 tan inverse of 2x minus 1 over radical 2. Sorry. Trying to write the parentheses and it shot it out. Plus some constant c. And we can clean this up. I'm going to get x minus 1/8 ln of, and that's the denominator, right, that we had. So the denominator that we originally had was 4x squared minus 4x plus 3, and then minus 1 over 4 radical 2. That's so sloppy. 1 over 4 radical 2 tangent inverse of 2x minus 1 over radical 2. And then, of course, we can't forget the plus c. And that's our answer. So thanks for pointing out the negative. I made a mistake in my work. I'm not perfect. It makes me sad. So if I can make a mistake, what do you think? What do you think is going to happen for you guys? Be very, very careful with these problems, okay?
Can you explain the whole -1 situation that just went down?
-1.
That you guys are talking about right now.
Oh, what I just talked about? Yeah. So I had here a +1, and it should have been a -1 because when I did the substitution, I didn't demonstrate the work. Going from here as my substitution for x, when I plugged that in, I just put +1. I forgot to subtract the 1, which made it become a -1/2.
Okay.
Does that make sense, Jason?
Yeah.
Okay. Yeah, just being meticulous about when you substitute, that you end up with the correct signs.
Okay. Thank you.
Yep. All right, do you guys have this one down? We still have 2 more marathon problems to do. How are you guys feeling?
It's all
My
right.
hand hurts.
It's all right.
Yeah, look, this is work. It is work, and I know it. And I'm sorry, but it's work. Okay. May I go on to the next problem? Or did it?
Yeah.
Man, I feel bad for the other like 8 people in our class that aren't here today. It's different to watch the videos when you can't ask a question. You know? So, honestly, the more you guys ask questions, the better the lecture is. So, ask. All right, let's get ugly. Here's the next problem. And so we can see it's already broken down for us, so we can decompose it, right? So this x, I'm going to write as a over x. And then we have a repeater, correct? So we have x squared plus 1, and then we'll have x squared plus 1 squared. Agreed? Now with that, since it's x squared plus 1, what should I put in the numerator?
B plus C.
dx plus d.
Bx plus c, right? Now the next one should be what?
D cubed.
No. So very close. It's the base that matters. So it's the x squared plus 1 that's dictating what goes up top. So it's the same as this one, but I need to use different letters. So I'm going to go dx plus e. Okay? So then in doing my cross multiplication and doing all those things, I'm going to have a times x squared plus 1 squared, correct? My bx plus c needs to be multiplied by x and by x squared plus 1. And my dx plus e needs to only be multiplied by x. Correct? Right?
Right.
Okay, so now we need to expand this thing. So, okay, let's get our expand on. So I'm going to get a x to the 4th plus 2a x squared plus a, agree? Plus, I'm going to do this all in my head, bx to the 4th plus bx squared plus cx to the 3rd plus cx plus dx squared plus ex. Do we agree?
Sure.
I'll give you guys a second to catch up. Sorry. Check me. I might be wrong. I just did it in my head.
Professor, just to be clear, so it's bx plus c, and then is it times x squared plus 1, or should it be plus x?
No. So it's
Parentheses x squared plus 1.
bx plus c times x squared plus 1. This x is coming from here, right? So the whole goal is trying to get a common denominator. So in this case, what does this need to have the correct denominator? It needs the x, and it needs one of these x squared plus 1s from here. So then this needs to be multiplied by x and by a factor of x squared plus 1. And that's what these are. Does that make sense?
starting to.
Yeah, it's just common denominators. If you want, I could show it to you this way. It'd be a over x. I need it to have x squared plus 1 squared to it. So what did I multiply the denominator by? X squared plus 1 squared. Okay? Then plus bx plus c. It already has x squared plus 1, but it needs x and another x squared plus 1. So that means I need to multiply by x and x squared plus 1. And then the dx plus e has x squared plus 1 squared. What does it need? It needs x, so I multiply by x. And you see how the numerator comes about. Right? Who would have thought that Algebra 2 would come back and be such a pain, huh? Does that help to write it that way so you guys can see it?
Yes.
Yeah.
Okay, well I can do the next one like that too, but that's what I've done with all of them. I've just taken for granted that we found the common denominator. That's where you guys asking questions is so helpful because, you know, it's things that are typically a little bit lower than this class level, but, you know, if you don't remember, you don't remember. You gotta ask, and it's okay to ask. I'm fine with getting you guys caught up. Just ask. Okay? All right, so I'm going to work from right here. So my x to the fourth terms, and if you want, we can write it this way too so you guys can see it. X to the fourth term, I have a plus b, and there's no other x to the fourth term. So what is that supposed to equal in terms of my numerator of my problem? So is there anything that's equal to x to the fourth in the numerator of our original problem? So what should we put?
Oh, 0.
0.
We should have 0. Now for the x to the third term, what do we have x to the third? It looks like we only have c, right? And c should equal what from our original problem?
-1.
-1. Perfect. Now let's go with x squared. And with the x squared term, I have 2a, I have a plus b, and it looks like I have a plus d, correct? And what is that supposed to equal? 2. Okay, so you guys are starting to pick up what things are being equal to. Now x, what are the x terms? I have c and a plus e, and what is that supposed to equal?
-1.
Perfect, -1. And then our constant, it looks like the only constant we have is a, and in our problem the constant was?
One.
It was 1.
1.
It was 1. So cool. So then from here what we can do is we can go, okay, sweet, I know a is 1. Do I know what b is then?
-1.
-1. What's c? -1. What's d?
Is it 1?
1. Good. What's e?
0.
Awesome. Sweet. So now we can try to break this thing down based off of this here. Okay? All right, so we're going to break this down here with our A, B, C, D, and E. So we have we have 1 over x, right? This is the integral, plus a negative x minus 1 over x squared plus 1, plus x over x squared plus 1, that quantity squared. And we could have put the plus 0, but the 0 is irrelevant, correct? And all of that times the differential dx. We okay? Okay, so I'm going to break it out. So integral of 1 over x dx, everyone knows that one, minus the integral of x over x squared plus 1, minus 1 over x squared plus 1. Oh, let's not forget the differentials with it. Plus x over x squared plus 1 quantity squared dx. What's the first one?
Natural log absolute value of x.
It starts flying, doesn't it? The next one, we've seen it so many times. 1/2 ln absolute value of x squared plus 1. You see how you just start memorizing them? Because you see them so many times. What was the trick to solve that one?
Substitution.
It's a u sub, right? It's a u sub.
U sub
That's right. Minus
ln of x squared plus 1.
oh, got you. It's the new rule from today, tan inverse of x.
Yeah.
That's one of the rules I taught you today, right?
That rule.
Mm-hmm. So when you see, if it doesn't have the root, right? If it's not rooted, if I had rooted x squared plus 1, then we would have used trig substitution. But since it doesn't have the root, we want to use the rule. Understand? There is a difference between this integral and this integral. This has the rule that I showed you today. This is a trig sub. Very small difference, but it changes the problem completely. Okay? Okay. And then we have this. Ooh, I want to be consistent in color. Then we have this other piece, and I'm going to do a u sub to it. And I end up with 1 over 2 times x squared plus 1 plus c. Do you want me to show that one?
Could you please?
Sure. So here I'll do it in a different color just so you guys can see it. So if I gave you the integral of x over x squared plus 1 squared dx, I'm going to say let u be 2x squared. Oops, no 2. I don't know why. But I was already doing the derivative. My bad. Du is going to be 2x dx. So then I'm going to get 1/2 du is my x dx, right? So then I'm going to get 1/2 the integral of u squared over du. Ooh, and actually, I made a mistake. Yeah, silly old me. It's a minus sign. So thanks for having me show it. This here now, I can do this integral as -2 du, right? And if I do power rule to that, don't I end up with bringing the power rule? I'm going to get 1/2 times a -2, then u to the -2 plus 1. Ooh, and this should be in the denominator. Not bad. Silly old me. That ends up in the denominator too. So I end up with a -2 plus 1. That's where you get the negative. So then I'm going to get a negative 1/2 u to the -1 power. And that gives me a negative 1/2 x squared plus 1 to the -1. Or you can just write it the way I did right here in the denominator. Cool? And I'll leave that work there for you guys so you guys can see it. There's a lot of kitchen work, right? One of my favorite professors, Dr. Mena at Cal State Long Beach, he used to say, there's kitchen work and then there's finished product, right? The work that you do behind the doors in the kitchen, it can be chaos and crazy, but when the plate is brought out to you, the plate looks beautiful. So, yeah. Did you have a question?
I said, is the plate the answer?
Yeah, it's the finished beautiful product, right? And so, you know, some of these integrals now, like this one here, oh, I see it. This one here, I see. This is the side work that goes into producing the work. Eventually, you'll get to the point where you can do this like me, but it's okay. Like for now, do your grunt work on the side. And then this is the solution to this problem. But look at how complicated this one problem was. Just this, we haven't even gotten crazy. With these partial fraction decompositions, right? We broke it up. We got ln that you've now become masters at. We did a u sub that becomes an ln. Then we had the rule for our inverse tangent. And then we had a u sub to break down to be able to solve a problem. There's 4 parts to this answer, and there's 4 techniques to solve each of the integrals. Have you guys noticed when I have something like this, I typically separate them? When you see something like this, if you can't u sub it to eliminate the whole thing, break up the numerator. Because that's x squared and that's x, I know that I'm going to be able to u sub that out. And then this one's so awesome, because that's just a constant, this thing's going to become either some special rule or some type of ln. Right? I've done it, probably the last 3 problems I've done where I've broken up a problem like that. So pay attention to that. It's subtle, but it's details that matter. Are you guys starting to feel a little bit better about this section?
Yeah.
Yeah. I mean, it you know, it's a lot of work though, right? There's a lot to it, and so yeah, be patient with yourself. And as you have questions, I'm figuring that probably what's going to happen on Monday is you guys are going to be like, Mr. Montiel, can you do? You gave us 6 problems. Can you do 1, 2, 3, 4, 5, and 6? Right. So it's gonna take some time. It's gonna be a lift because all of your integration techniques are gonna come into play. Right. All your problem solving is gonna come into play. And so, make no mistake, you're gonna spend some hours doing some homework on this. I mean, just for me to write my notes and to work these problems out and write them out, took me about an hour and a half. So, and as you can see, I skipped steps. Like I'm like, oh, the matrix. I just typed it in my calculator and got what the answers were to the matrices. And then some of the integrals that I already know, that I don't have that side work with the blue. I just had the answer. So it's a thing where when you guys need to break it down, each one of these integrals, they're each legit integrals. They're going to take some time. So be patient with yourself, but don't get disheartened either. You'll get through it. It's like that guy I always talk about, Sir Andrew Wiles. He was an English mathematician who solved Fermat's last theorem. Right? Fermat's last theorem was over 400 years old, and this guy had spent 10 years of his life in his attic trying to solve the problem. And he came out and there was a big to-do about how he had solved it and all this stuff. And then the math gods, right, the guys who decide, looked at his work and they realized he had made a sign mistake early in his work, early in the years of his work. And it turned out he hadn't solved it. So then he went back to his attic for another 3 years and then he finally solved the problem. I mean, that's a dude with a PhD in mathematics who gave up everything to solve a math problem. And then to think that after a decade you had made a mistake. At least he persisted and kept going. So you guys should persist and keep going. All right. One last problem to demonstrate for you guys, and we'll go from there. Okay, so for this problem here, this is a unique situation. We're going to do a U-sub to this problem, but not in the way that you would think. Okay, I'm going to do a U substitution that's a little bit funky. So I'm going to call a U substitution of this the square root of x plus 4. But instead of taking the derivative, because I don't want to deal with roots, I'm going to square both sides. So I'm going to say U squared is equal to x plus 4. You guys agree with that, correct?
Yeah.
Okay. And then what I'm going to do is I'm going to go U squared minus 4 is equal to x. Okay. And now from here, I'm going to do my derivative. So I'm going to end up with 2u du is equal to dx. Okay. So now when I go to do my substitution, I know that the square root of x plus 4 is u. Agreed? I know that the x in the denominator is equal to u squared minus 4. Agreed?
Yeah.
And then my dx is equal to 2u du. Are we in agreement? Okay, so then from here, the integral is I'm just going to pull the 2 out all the way. I'm going to get u squared over u squared plus 4 du. And what does this problem look like? If the number on top would have been a constant or something, maybe we could have used that rule that we had today, right?
Montel, how'd you go from minus 4 to plus 4 again?
Oh, because I'm really positive. Don't judge me, man. I don't know. I like changing my signs. You know, I just told you a long story about a guy making a sign mistake. Okay, so then from here, what we see with this problem is this is a problem that qualifies for long division. So I'm going to do long division to this thing and go u squared divided by u squared minus 4. So I'm going to get 1, and I'm going to get u squared minus 4 subtracted. It's going to leave me with a positive 4. And so I can break this up to be 2 times the integral of 1 plus 4 over u squared minus 4 du. Right? Again, we're doing long division to break this up. Are we okay with that? So then from here, I'm going to have two integrals. I'm going to have 2 integral of du plus 8 integral of du over u squared minus 4. We okay? And what sucks here is if this would have been a plus, we could have used that rule that I gave you already, right? Well, it turns out if it's a minus, there's another rule. And here's that rule. So if I have the integral of dx over x squared minus a squared, I'm going to get 1 over twice a ln of x minus a over x plus a plus some c. So what we end up noticing here is the factors of the denominator. The minus is on top and the positive is on the bottom. If you want me to do the proof to these rules, I can do them. I just didn't want to waste the time today to do the proofs. But if you guys eventually want to see the proof to why that rule is what it is, I can do it. Okay? Does everyone agree with how I got the 4? I mean, how I got the 8 there in front of the integral? Okay, so then when we go to do this, I'm going to get 2 times u plus 8 times, my a in this case is 2, so 2 times 2 is 4, so I'm going to get 1/4 ln of the u minus 2 over u plus 2 plus some constant c, right? But now what we need to do is we need to remember what was our u. Wasn't our u square root of x plus 4? So now I'm going to go 2 times square root of x plus 4 plus 2 times ln square root of x plus 4 minus 2 over square root of x plus 4 plus 2 plus c. How many problems did I do?
6.
7? 7 problems? Took an hour and 40 minutes? Are there any questions on any of these? No? All right. I'll stop recording right here because I don't want to bog down my computer. If it stops, if I get booted, that means we lost the video. Hopefully that doesn't happen. I'll let you know when I'm about to press the button. But I don't want to make the video too long and then potentially lose this stuff, okay? Then I'll answer homework questions for you guys. So here we go. Cross your fingers.